Hey guys, welcome to the shop. This week we're repairing the worst of the two broken Monarch Lathe handles that I have. We got some mill work, we got some lathe work, and we also have some heavy slotting on the shaper, which I think you'll enjoy. Just do it for fun, but you get the idea. I like running this machine. We also balance an aluminum CBN grinding wheel, which you don't see very often. So, you know, typical machine shop repair stuff. So thanks for watching, guys. Let's get started. So here's a Monarch Lathe handle that was sent to me. I showed this on last week's video. That's got a really bad break out here on the end that needs repaired. Now, I don't have the piece that broke off here, unfortunately. If I did, it would make this repair a lot easier. So without having that, I'm going to have to remake this whole end. Now, I was sent this piece here for reference. That's what it actually kind of should look like. So I think that I've got a plan to get this thing back to where it'll function. I do luckily have some of the original bore left here that I can use to align this on the milling machine. And what I think that I'm going to do is mill a flat here that's true to the bore, and then front and back. Then I'm going to go over to the lathe, make a piece that looks like this, do a little milling on it, hand fit it to this, and braze it back on. I think that's my best bet to get this thing repaired and keep that original alignment. So let's go over to the milling machine. Let's see if we can get this crazy thing dialed in, and you know, we'll go from there. Alright, so I've got my part here just snug in the vise so I can tap it around. I've got the bolts of the vise loose, that way I can, you know, align this pin. This needs to be true with the movement of the table and, you know, vertically. So to hold this down, this pin is loose in this bore, and you can't indicate off that. So I'm just going to use a little beeswax. Beeswax, you can use clay. I've got both here. Either will work, just something to hold it stationary to where it can get a good reading off of it. It'll be good enough for what we're doing. And then I'll indicate this in, and then we'll go from there. Alright, so I'm just going back and forth on this thing, working the top of the pin, indicating on the top, and then indicating on the side, so I can get this thing aligned both vertically and horizontally. Just back and forth, you know, getting on the center of the pin each time, you know, bumping this thing around the vise and then the part. Well, that's pretty decent on the side. It's well within reason. And we'll check the top here. Okay, so that's good enough. Now I'll just tighten down the vise and recheck, and then we'll mill this. So in case it's not obvious, the reason I'm machining the top of this handle here in line with the original bore is just so when I make that piece to replace the broken off piece in the lathe, I can fit it accurately to this handle. I'm definitely glad that there was at least some of that bore left to indicate off of and align off of. Otherwise I'd be blind, not having the entire piece of equipment to, you know, reference off of. Good enough. Just give us some good true surfaces. So that was easy enough. At least now we have something to go off of. That's the whole idea of machining those surfaces. Just left that gear in there, took the pin out, left the gear in there, so when I clamped on this, you know, I didn't risk breaking these ears. So we've got a piece of cast iron here that we're going to be turning into the rest of the piece here. This could be steel. Where we're going to be brazing this, joining dissimilar metals, within reason, is not that big of a deal. Right now it's 31.9 millimeters or 1.25 inches, or raw stock. We need to turn the major OD down to 1.25 inches, so we need to remove 1/8 of an inch, or 28.8 millimeters. We also have to turn the end of our stock down to make that protrusion there. And that is 21.8 millimeter, or 858 thousandths by probably, I don't know, 3/4 of an inch, 5/8 of an inch long, 3/4 of an inch, or 19 millimeter. So should be pretty basic, I think. We'll have to also drill it and ream it for 1/2 inch. Then we'll take it over the mill and start machining on it to try to get the best fit that we can. So I had to take really light cuts on this piece. If you look at how much I'm actually holding it in the chuck jaws, you'll see why. There was just enough of this stock here to make the part that I needed, and you do what you gotta do. It worked out, but just couldn't hog away at this thing, so I just took it easy. So the plan here was just to drill this hole out, run a reamer through it. Not that it needs to be reamer accurate, but that's what I wanted. But I had some issues. My drill wanted to wobble for some reason. If you look at it here, you can see that it just didn't drill concentric. So I decided to just bore this thing out and then run a reamer through it. If you want a bore that's concentric on the lathe, I think using a boring bar is probably your best bet. So it's a neat little reamer that I'm using here. Maybe some of you are aware of them. Just an adjustable reamer. This one happens to be 1/2 inch, but you can go larger than that, and that's what I'm doing. I just want to hold it slightly bigger than 1/2 inch. And I'm using a Scully Jones quick change holder here. just substituting that for a floating reamer holder, which I don't own. All it does is not hold that reamer completely in line with the tailstock and allows it to follow the hole that I bored. It works pretty well. Not its original intended use, but it works. Alright, so I need a short threaded section in the end of that, 9/16 18. It just needs to screw in up to the tape there. Using my shop-made tap guide here in the tailstock. Just gonna run this in a bit, stop and check, and you get the idea. Cut a little more, stop. Good enough. And after this, I'll just turn off the part of the work that I'm using to hold on, and then take it over the mill and start trying to fit it. I think it's good enough. So right now this part's just snug in that collet because I want to align those marks that I made, just rough, guidance lines really. I want to align them. That way, I'm not having to stop 500 times. I'll just machine down close to these, and then I know I'm really getting within the ballpark. Just holding these two squares together to give me a raised parallel plane with the table. Just trying to line it up by eye. That's good enough. I'll take this out, tighten it up in the block, and we'll start machining it. we go. That should be good enough, I think. You know, once this is going to have to be hogged out and then brazed up and then a reamer run through it. So not too worried about it. It'll be very close to its original alignment and should work just fine, I think. So this broach bushing that I used to cut the keyways and the pulleys of the dual saw, a lot of people wanted to see it either done on the shaper or on the horizontal mill. I done it on the vertical mill, but for demonstration I decided I'd give this a shot, just for fun. There's also a lot of confusion on how do you center up your tool over your work on a shaper. It's just not obvious for a lot of people. The main thing is that your compound has to be square, clapper needs to be square, and you also have to square the tool on a shaper or else you're not going to get a good result. But anyway, I touch my cutter off the top of the work. I come down half the thickness of the work, and then I touch the side of my cutter here to the work, just like you'd use an edge finder on a vertical mill, just like you would use the cutter on a horizontal mill. Come over half the thickness of the work, and then half the thickness of the cutter, and that'll get you on center. It's pretty simple, really. People have been doing slots with the shaper for over 100 years, and this will get you plenty close enough in most cases. So that's it. I just need to come over 1.591 inches, and that'll get this cutter on the center, and we'll slot it real quick. That done pretty good. If I had to do over, I'd probably give a little more positive cutting action on that cutting edge. That's over 3/8 of an inch wide and 3/16 stainless, so it does good. So there's the slot that I milled, and it finishes good. And then there's the one that I done on the shaper. In some ways the finish is a little better, but I don't guess it really matters. Same outcome. Just takes longer on the shaper. That's the only downfall to that machine. So what originally attracted me to the shaper was the fact that you could get, tooling really cheap. A handful of high-speed steel you could grind in a bench grinder. You could grind any profile you wanted on the high-speed steel and impart that on your work. You could do keyways, internal, external, racks. I mean, you name it. It's a pretty versatile machine. And at the time that I got that shaper, before they became real popular, they were pretty much giving shapers away. You could get them for the scrap price, and sometimes you still can. But they are a handy tool, whether you're in a job shop for those one-off jobs, or you're just in your home shop. They're definitely a valuable tool to have. That's as far as I'm going to get this week. I was hoping to join these two together. Man, that really turned out good. better than I expected. I didn't know what I was going to do with that, to be honest. I just kind of rolled with it, and it all kind of worked out. So my original intention was to braze this together. I even mentioned it in this video. That's what I was going to do. Just like I did this part on last week's video. You know, my mind was set. But I shared my progress where I'm at right now with this on Instagram. You can follow me over there if you're interested. Anyway, Mr. Robin Renzetti, he follows me, I follow him. He suggested that instead of brazing this thing together, that I silver solder it together. And I think that's a great suggestion. We've got a lot of surface area here where these two parts join, and this would be more than strong enough and give me a much cleaner repair. This won't require the heavy burring, you know, the material removal that braze does, or the large cleanup. So thank you, Robin, for the suggestion. Go check him out. He's a true master at all things metal and probably others, but you know, he's a guy that gives all sorts of information that you just can't get anywhere. If you want tips, man, he's got them. So thank you. So that's it this week. Merry Christmas, Happy Holidays to those who celebrate. If you don't celebrate, you know, take some time off with your family and enjoy yourself anyway. Click on my little guy if you want to subscribe to the channel. I'd appreciate it. Huge thanks to my viewers, my patrons, my subscribers. Like I say every week, I mean it. That's it. Send me an email if you need anything. And I'll see you next time.